Hello and welcome to the Wave Solver program for your TI-84 Plus CE or TI-84 Plus CE Python calculator. It's a boutique program from MCS Tutoring designed to solve the programs on this Waves PDF worksheet. So look, just so you know too, speed and velocity, I know in your physics class, they're two separate things. For most human beings, they're the same, so we're going to use those terms interchangeably. If you're a physics person, flame me in the comments. It's okay. It's okay. Okay, so first thing, we're trying to find the velocity of this wave. So I'm going to go option 1 here for velocity. And then look, what we're going to do, oh, by the way, we're going to use L for lambda. I know that's wavelength. So wavelength here is 3.8 meters. We just want to make sure we use the right units because I'm a math person and I'm not really good at that sometimes. Use period or frequency. We're going to be using period because that's what we're given. We're given the period and the wavelength. So we're going to be using period, option 1. And then what is the period? So it's 1.7, and it is in seconds, so we're okay. And it looks like the velocity is, for this one, 2.235. I'm just going to go 3 decimal places, meters per second. Okay. I don't have a diagram for number 4, so we're going to skip that one. We're going to do number 6, though. It looks like we're talking about string properties here. So string props. And then what are we doing? It looks like we have a mass. We want mass per unit length. That's the question, mass per unit length. Has a length of 0.64 meters, mass of 4.3 grams, which is 0.0043 kilograms. Tension of 75.6 newtons. So we want to know mass per unit length, option 1. So the mass is in kilograms. So that's me having to pay attention here. 0.0043. There we go. And then the length is 0.64. And it looks like it's 0.006. I got to pay attention myself. Okay, 0.00672 kilograms per meter. Okay. I'm not sure how tension goes in here. So if I'm mistaken, actually go ahead and flame me in the comments if I do make a mistake. I'm definitely happy to debug this program. Okay, next one. String in exercise 7. I don't have that, so that's not happening. Okay, frequency of a sound wave with a wavelength of 0.56 meters traveling in room temperature air. So I think we're trying to find sound frequency here. Option 4. And the speed of sound here in room temperature air. So it is affected by the temperature. So in this case, it's 340 meters per second. And then the wavelength is 0.56. Okay, it looks like it's got 607.14. I'm going to go round it up to 3 hertz. And that's beats per second. That's what hertz means, by the way. So we're going to go on. Suppose you start a major scale in concert A, which is defined to have a frequency of 440 hertz. If we call this frequency do, I'm not sure if a lot of you are familiar like do, re, mi, fa, sol, la, ti, da. What is the ideal ratio frequency? In other words, using just tuning of the following. So I think this is a sound frequency problem, or is it a music tuning? Let's try music tuning. We're tuning ratios, I think. I hope. Okay, base frequency 440. Okay, so the re is 495 hertz. And the sol is 660 hertz. Okay, good. I was guessing at that. I just made this program, so I forget what's what. It's not like I'm using it all the time. In just tuning, the ratio for major third is 5:4. In equally tempered tuning, the ratio is 1.260. If we start a scale on a frequency of 880 hertz for do, what is the difference in frequency for a mi on an equally tempered piano and a justly tuned piano? Okay. I hope this works. I think we're going to do music tuning, and we're talking about tuning difference. And then the base frequency is, it looks like it's 880 hertz. And then the just is 1100. And then, let's see, equal is for the 1.26, 1108.8, and difference is 8.8. Oh my goodness. I don't even know what this means. So I hope this is right. Honestly, I don't know. I'm a math guy. I feel like this is John Searle's Chinese language room argument from philosophy class. It's like, I don't even know what I'm doing. But I know how to do math. I hope this is right. Oh my gosh. We're going to do beats here. What's the first frequency? It's 352 hertz. So 352. And then what's the beat frequency? This is 7 beats per second. That's like, I think 7 hertz actually. And then, so it looks like we've got possible F2 values. Second string is 359 or 345. Again, I hope this is right. I don't have an answer key. I don't know what I'm doing. If this is right, like it or make a comment. If it's wrong, flame me. I'll fix it and make an adjustment to this program. But otherwise, good luck with all your physics stuff, all your waves, and may you do well. And I'll see you next time.